Hi guys, welcome to Unacademy KCET YouTube live session. Myself Sharif, teaching IIT JEE Mains and Advanced Math from past 16 years, taught math in India as well as abroad. Currently working as head of the maths department and vice principal of Giraffe Learning. Afrin, hi. Good morning. Yes guys, before I take up the session, okay, I would like to tell you guys, if you're new here, alright, please subscribe and enable the bell icon so that you get notification of all our classes. There is YouTube live classes, right? So so welcome to all the newcomer guys. Welcome to all the newcomers here. So before I start the session, right, let me tell you about Unacademy Plus subscription, India's largest online learning platform. So for 12 months, plan for 12 months, it's 12375. That is, it will cost you 1031 per month. Enter this referral code, you get 10% discount. And for 6 months, it's 10125. Enter this referral code 1688, you get 10% discount. That is 1688. It will be per month. That is 10125 for 6 months. That is 1688 per month. Enter this referral code, you get 10% discount. And per month it's 12250. That's a throwaway price in Bangalore. Enter this referral code, you get 10% discount. It covers all this premium content. It covers all this. It's actually premium content at affordable price, structured live courses plus dedicated live doubt clearing sessions, quizzes at regular intervals, batches for complete preparation, test series for DPP. There is daily practice papers, full length mocks. Single subscription for unlimited access. Okay, so in plus classes it will be in detail. Alright, so before I start guys, so this will be now today's first session will be on previous KCET and Comet K MCQs on limits, continuity and differentiability. So we have covered in this all the YouTube classes, around 6 classes are there on this limits, continuity and differentiability. It covers all the questions from 2004 to 2020. KCET and Comet K questions. So let me start guys. Here we go with the first question. Alright, now question number 1. Function is continuous at x is equal to 2. Then what should be the value of k? Right, so Ukesh Kumar, hi, welcome to class. Welcome to YouTube live session. Ayan Khan, hi, good morning. Alright guys, so the function is continuous at x is equal to 2. What should be the value of k? Don't use the both method. Alright, now let me tell you guys, listen, it's continuous at x is equal to 2. If it is continuous at x is equal to 2, obviously left hand limit is equal to right hand limit. That's what you do in boards as well, right? So it's continuous at x is equal to 2, left hand limit should be equal to right hand limit. Now what I'll do is less than 2 will be left hand limit, less than 2 will be left hand limit, more than 2 will be right hand limit. I'm going to take 2 less than 2 and take 2 and substitute here. You will get this as k into 2 square. K into 2 square, that will be left hand limit. Okay, and more than 2, obviously it's a constant that's already given in the question. This will be 3. Right, so you will get this as k into 4 is equal to 3 and k is equal to 3 upon 4. That's it guys. Within 30 seconds you get the answer. Less than 30 seconds in fact, answer will be equal to 3 by 4. So no need to do that board method where you apply limit x tends to 2 minus x tends to 2 plus. Okay, no need, avoid all the steps. Directly you can do it. Answer will be equal to 3 upon 4. Let's move to the next question. If the function satisfies that limit x tends to 2 f of x minus 2 upon x square minus 1 equal to pi, then what should be the limit of the function as x tending to 1? Right, now if I apply algebra of limits, 2014 question, limit x tends to a f of x upon g of x, limit x tends to a f of x upon g of x, same as limit x tends to a, this will be equal to f of x upon limit x tends to a and g of x. that is limit of numerator upon limit of denominator, that is algebra of limits. So I'm going to apply this algebra of limit, guys. Okay, now this will be equal to limit x is tending to 1, limit x is tending to 1, limit of numerator, that is f of x minus 2, okay, upon limit of denominator. Limit of denominator will be equal to limit x is tending to 1, limit x is tending to 1, you get x square minus 1 equal to pi. Right, now this can be written as limit x is tending to 1, f of x minus 2, right, upon x is tending to 1, you get 1 minus 1 is equal to pi. So obviously this is 0, guys, this will cancel. So I can write limit x is tending to 1, limit x tends to 1, f of x minus 2, right, upon 0 is equal to pi. I'm going to cross multiply. So this becomes limit x is tending to 1, limit x tends to 1, you get f of x minus 2 is equal to 0. If I cross multiply, right, minus 2 you shift on the right side. This can be written as limit x is tending to 1, limit x tending to 1, f of x is equal to 2. That's the answer, guys. Answer is option B. Hope this is all simple only, guys. Very simple. Just cross multiply, it will be 0. Minus 2 you shift on the right side, it will be plus 2. Alright, let's move to the next question. Function is continuous at x is equal to 0. Function is continuous at x is equal to 0. What should be the value of k? Right, so we know that if it is continuous, usually how do you write? If it is continuous, you're going to write like this, right? Limit x tends to a, limit x is tending to a, f of x is equal to f of a. Na? If it is continuous at x is equal to a, that's what you do. If it is continuous at x is equal to 0, then I'm supposed to write limit x is tending to 0, limit x is tending to 0, f of x is equal to f of 0. Right, it's already continuous at 0. So write limit x tends to 0, f of x is equal to f of 0. So this can be written as limit x is tending to 0. Limit x is tending to 0, right? F of x will be equal to 3 into sine pi x, 3 into sine pi x upon 5x, okay, is equal to f of 0. That's already mentioned in the question. At x is equal to 0, fx is equal to 2k. So this will be equal to 2k. Alright, I'm going to take 3 by 5 out because it's a constant now. Okay, limit x is tending to 0 of, you get sine pi x divided by x is equal to 2k. Right, is equal to 2k. Now listen. Let me tell you here itself, listen. When you have suppose like this, limit x is tending to 0, limit x is tending to 0 sine ax divided by the limit sandwich theorem, limit x tends to 0 sine x by x will be equal to 1. Yeah, if I write like this, limit x tending to 0 sine x by x is equal to 1, that is sandwich theorem, right? I can also write, if I have suppose limit x is tending to 0, limit x is tending to 0 sine ax upon ax, only then this will be equal to 1. It should be sine ax upon ax. So if I have suppose limit x is tending to 0, right, sine ax upon ax, right, this will be equal to 1. Right, now if you have suppose like this, limit x is tending to 0, right, very useful, listen, sine limit x tends to 0, if you have suppose sine 5x divided by x, no need to multiply and divide by 5, directly this is equal to 5. If I have suppose like this limit x is tending to 0, okay, limit x is tending to 0, sine 6x divided by x, directly you can write 6. So same logic guys, right? No need to use multiply and divide, nothing. Alright, entrance, skip the steps. I want only option in the exam. This is 3 upon 5. Okay, 3 upon 5, limit x tends to 0, sine pi x divided by x will be equal to pi, right? Two examples, couple of examples I have given on the right side. So sine pi x divided by x will be equal to pi, and that's equal to 2k. Okay, I'm supposed to find the value of k, right? This is equal to 3 pi upon 2, you shift in the left side, you get 10 is equal to k. So k is equal to 3 pi by 10. So answer is 3 pi upon 10, answer is option B. Yes guys, simple only, right? Let's move to the next question. Question number 4. Alright, now follow carefully. If suppose x tends to 0, okay, I'm going to get here cos 0 divided by 1 minus cos 0, right? Cos 0 is 1, na? You get 1 minus 1 upon 1 minus 1. So this will be equal to 0 by 0 form, right? Now note this. Whenever you have very useful guys, whenever you have limit x is tending to a, right? In general I wrote x is tending to a, fx upon gx. If this is of the form 0 by 0 or infinity by infinity, right? Limit x tends to a, fx by gx is of the form 0 by 0 or infinity by infinity. Differentiate numerator and denominator separately. Okay, differentiate numerator and denominator separately. Differentiate numerator and denominator separately. You understand? This is actually called L'Hopital's rule. It is written as L'Hospital's. H and S is silent, so it should be read as L'Hopital's rule. L'Hopital's rule. So I repeat myself, guys. Whenever you have a function which is tending to 0 by 0 or infinity by infinity, differentiate the numerator denominator separately. That is called actually L'Hopital's rule. H and S is silent. Don't read this as L'Hopital's rule. Don't read this as L'Hospital's rule. Read this as L'Hopital's rule. H and S is silent. So 0 by 0 or infinity by infinity, differentiate the numerator denominator separately. So if I use this logic, there are many questions where you can use this technique, guys. So this is 0 by 0 form. So follow carefully. Very useful. Limit theta tends to 0. So I'm getting 0 by 0 form, right? Differentiate the numerator. Differentiation of 1 is 0. Alright, hope you know no differentiation, guys. Differentiation of cos is minus sign. So minus will become plus. This will be equal to 4 sine 4 theta. Okay, that is I'm using L'Hopital's rule. Let me write here. I'm using L'Hopital's rule. Right, so differentiate numerator denominator separately. So I differentiated the numerator. Differentiation of 1 is 0. Okay, let me write this once again. So if I use L'Hopital's rule, differentiation of 1 will be 0. Differentiation of cos is minus sign. So this becomes 4 sine 4 theta. Right, upon, again differentiation of 1 is 0. Differentiation of cos is minus sign. So this will be equal to 6 sine. This will be equal to 6 sine 6 theta. 6 sine 6 theta. Right. So 4 upon 6. So I'm going to keep limit as it is. Right. So I'm just using L'Hopital's rule. Limit I'll keep as it is. So this is limit x is tending, limit theta tends to 0. Differentiate the numerator denominator separately. Okay. I'm going to cancel this. This is 2, this is 3. So I'm going to take 2 by 3 out. Right, limit theta tends to 0. Limit theta tends to 0, sine 4 theta upon sine 6 theta. Right, no need to use L'Hopital's. If you want, you can use L'Hopital's rule, guys. Again, you get 0 by 0 form. Or, okay, now listen. Whenever you have like this, limit x is tending to 0. Okay, sine ax divided by sine bx. No need to multiply and divide. Directly you can write a upon b. Right? Even you have, so let's say if you have like this, limit x is tending to 0. Okay, sine 3x upon tan 5x, combination of sine and tan. Okay, directly you can write 3 upon 5. Very useful. Any question? Sine 3x upon tan 5x, write 3 upon 5. So this is sine 4 theta by sine 6 theta. Alright, so directly you can write this as 4 upon 6. Okay, 4 upon 6 will be, here you get 2 upon 3. 4 upon 6 is 2 upon 3. 4 upon 6 is 2 upon 3. You multiply, you get this as 4 upon 9. So answer is option C. Alright, so whenever you get 0 by 0 or infinity by infinity form, just differentiate the numerator denominator separately. That's called L'Hopital's rule. Okay, let's move to the next question, guys. Sorry guys, there was some, my internet got disconnected. Alright, let me start. Alright guys, so you get 0 by 0 form, right? So when you get 0 by 0 form, let us use L'Hopital's rule. Alright, let me write here. Okay, so I'm going to use L'Hopital's rule. So using L'Hopital's rule, 0 by 0 form, right? So I'm going to use L'Hopital's rule. I'm going to differentiate numerator denominator separately. So this becomes limit x is tending to 0 of, right? Now let us differentiate. First function is x. Differentiation of e power x is e power x. Plus second function is e power x, and then differentiation of x is 1, right? And then differentiation of sin x will be equal to cos x. So upon differentiation of x is 1, right? Now x is tending to 0. X is tending to 0, this becomes 0 into e power 0 plus e power 0 minus cos 0. Right, so note this step, 0 into e power 0 obviously 0. So this becomes e power 0 is 1, cos 0 is 1. So you get 1 minus 1 is equal to 0. Answer should be option B. Right, so let's move to the next question, guys. Okay, question number 6. Now function is continuous at x is equal to 1. What should be the value of k? So it's already continuous at 1, right? So I should write this as limit x is tending to 1. Limit x tends to 1, f of x is equal to f of 1. Limit x is tending to 1, f of x is equal to f of 1. So I'm going to write this as limit x is tending to 1. Limit x tending to 1 f(x) is equal to log x. Okay, it's understood as base c. Even if e is not there, base c only, right? Upon x minus 1. X minus 1 is equal to limit x tends to 1 f of x is equal to f of 1. That's given in the question. It's already continuous. So this fellow is f of 1. Alright, this is given in the problem. It's continuous at x is equal to 1. This condition is already given. Right, so it's given in the question that at x is equal to 1, f of x is equal to k. So this becomes k. Alright, now this is of the form 0 by 0. Log 1 to any base is 0 upon 1 minus 1 is 0. You get 0 by 0 form. So I'm going to use L'Hopital's rule. Right, I'm going to use L'Hopital's rule. So differentiate the numerator denominator separately. So limit x is tending to 1. Limit x tends to 1. Differentiation of log x is 1 by x. Okay, and differentiation of 1 is 0. Differentiation of x is 1. Differentiation of 1 is 0. And that's equal to k. Right, now x is tending to 1. If x tends to 1, you get 1 equal to k. 1 is equal to k. So answer is option B. Right, just use L'Hopital's rule, guys. Alright, next let's move to the next question. Question number 7. Alright, good question. Function is continuous at x is equal to 0. Find the value of k. So it's continuous at 0, right? Less than 0 will be left hand limit. More than 0 will be right hand limit. So let's do one by one. Left hand limit is equal to limit x is tending to 0. Root of 1 plus kx. Root of 1 plus kx minus root of 1 minus kx. Right, divided by x. Now if x is tending to 0, I'll get this as 0 by 0 form. Okay, you get 1 minus 1 upon 0. So let us use L'Hopital's rule. So let me write here. Using L'Hopital's rule, this will be equal to limit x tends to 0. Okay, differentiation of root x is 1 by 2 root x. 1 by 2 into root of 1 plus kx. Alright, differentiation of kx is k. Again, root x is 1 by 2 root x. Alright, differentiation of 1 is 0. Differentiation of minus kx is minus k upon 1, because differentiation of x is 1. Now this can be written as limit x tends to 0. You will get this as k upon 2. Minus minus is plus, k upon 2 will be equal to k. This is left hand limit. Right, so less than 0 will be left hand limit. More than 0 will be right hand limit. So if I take right hand limit is equal to limit x is tending to 0 of, right, what is more than 0? You get 2x plus 1 upon x minus 1. This is direct, guys. If x tends to 1, x tends to 0, directly this is 0 plus 1 upon 0 minus 1. You will get this as minus 1. Right, so it's already continuous. So left hand limit, it's already continuous, so left hand limit is equal to right hand limit. Okay, this condition is given in the question. This is given. Right, so what is left hand limit? Left hand limit, I got k. K by root x is 1 by 2 root x, k by 2 plus k by 2. Left hand limit is k, right hand limit is minus 1. Okay, so answer will be equal to minus 1. It's B. Good question. So it's already continuous. Left hand limit is equal to right hand limit. Find out left hand limit, right hand limit, and equate them. You will get the value of k. Alright. Question number 8. It is continuous at x is equal to 0. Find the value of k. So if it's continuous at x is equal to 0, I can write limit x tending to 0. F of x is equal to f of 0. Okay, now this is equal to limit x tends to 0. F of x will be equal to sine 3x. Sine 3x upon e power 2x minus 1 is equal to f of 0. When x is equal to 0, if I substitute here, you will get this as k minus 2. Alright, now this is actually 0 by 0 form, because sine 0 is 0, e power 0 is 1, so you get 0 by 0 form. Now I'm going to write this as limit x tends to 0. Limit x tends to 0, use L'Hopital's rule. Let me mention here, 0 by 0 form, you should use L'Hopital's rule, very useful. Using L'Hopital's rule. Okay, don't use L'Hopital's rule in the board exam, guys. Alright, PUC, CBSE, you have to use the normal method only, no L'Hopital's rule. In fact, ISC students have L'Hopital's rule, but state syllabus and CBSE, you don't use L'Hopital's rule in boards. Limit x tends to 0. Differentiation of sine 3x is 3 cos 3x. Okay, and then differentiation of e power 2x is 2 e power 2x. And differentiation of 1 is 0. And that's equal to k minus 2. Right, let me simplify this. X tends to 0, right? You get 3 into cos 0. Cos 0 is 1 upon 2 into e power 0 is equal to k minus 2. Cos 0 is 1, e power 0 is 1. 3 upon 2 is equal to k minus 2. Shift minus 2 on the left side. You will get 3 upon 2 plus 2 is equal to k. So you get k is equal to 7 by 2. Okay, that's the last option. K is equal to 7 upon 2, that's the last option. Okay, another 2 questions we'll do it, just 5 minutes guys, less than 5 minutes. Okay, question number 9. Okay, now listen, extending to 0, you will get this as 0 by 0 form. Because you get f of 2 minus f of 2 upon f of 1 minus f of 1. Right, you get 0 by 0 form. So I'm going to use L'Hopital's rule, follow carefully. Using L'Hopital's rule. Okay, using L'Hopital's rule, this will be equal to limit h tends to 0 of, if limit h is tending to 0, differentiate with respect to h. Differentiation of f is f dash into 2 plus 2h, okay, plus h square. Okay, into differentiation of inside expression 0 plus 2 plus 2h. That's how you differentiate, right? Differentiation of f is f dash, and then you differentiate the inside expression, chain rule. The composite function of a function. Okay, now differentiation of f will be equal to f dash into 1 plus h minus h square. Right, differentiation of 1 is 0, differentiation of h is 1, differentiation of h square is 2h. I'm just using chain rule guys, your L'Hopital's rule, differentiate the numerator denominator separately. Now h is tending to 0, this becomes f dash of 2, okay, into 2, h is tending to 0 now, divided by f dash of 1. F dash of 1 into a bracket into 1, because h is tending to 0. Now let me substitute the values. That's equal to, what is f dash of 2? F dash of 2 is 6 into 2 upon f dash of 1 is 4. You will get this as 4 into 1. Okay, you will get this as plus 3. Answer is option C. Yeah, Afrin, that's right, that's fine. Previous question number, Afrin, tell me which question, but it's log e power x. Where is it log, which, no, it's not log e power x. Afrin, that's not log e power x, that is log e to the base, log x to the base e. It's a previous KCET question only. What you use in the lab, that is to the base 10. This is log x to the base 10. That's called a common log. You understand? When you write log x to the base e, that is called the Neperian log. Alright, that is called the Neperian log. Log x to the base e. This log x to the base 10. What you use in the lab, this is the log x to the base e. You understand? Are you getting my point? So that is log x to the base e. Alright, hope the concept is clear. Alright, whenever you write in calculus, it is understood it is the base e. Whether it is board or entrance or what it may be, whenever you write log x, it should be the base e only. Alright, other than base e, you should use change of base formula and then differentiate. Alright, let's use do the last question, guys. Okay, very good question. It's continuous at x is equal to 0. So I should write limit x is tending to 0. Okay, f of x is equal to f of 0. This was asked in CET, it was asked in 2015 JEE Main as well. 2014 JEE Main. Limit x is tending to 0. Okay, and then this should be equal to sine of pi into cos square x. Pi into cos square x upon x square. Okay, is equal to f of 0. X is tending to 0, you will get this as 0 by 0 form. Now I'm going to use L'Hopital's rule. Okay, so I'm going to use L'Hopital's rule. So limit x is tending to 0 of differentiation of sin x is cos x. This will be equal to cos of pi into cos square x. Okay, then pi is a constant. Differentiation of cos square x is 2 cos x into minus sin x. Okay, and then whole divided by differentiation of x square is 2x. And that's equal to f of 0. Note this step, guys. 2 and 2 cancels. Sin theta by theta is 1. That is Sandwich theorem, na? When you have suppose limit x tends to 0, sin x by x is equal to 1. So this will be 1. Sin theta by theta is 1. Okay, now x is tending to 0. You will get this as cos of pi into cos 0. That is anyways 1. Cos 0 is 1. Into pi. Into cos 0 is 1. Into minus 1 is equal to f of 0. Now this is equal to cos pi. Okay, into pi into minus 1. Cos pi into minus 1 is equal to f of 0. Cos pi is minus 1 into pi into minus 1 is equal to f of 0. You will get f of 0 is equal to plus pi. Answer is option D. So I'll stop here, guys. We will continue further in the next YouTube session, that is on 8th. Alright, 8th of this month, 11 in the morning, 11 a.m. Alright, guys, before I wind up, let me tell you once again, let me remind you about the Unacademy subscription. If you're looking for a 12 months plan, it will be 12375, that is 1031 per month. And if you're looking 6 months plan, it's 10125, that's 1688 per month, and per month it's 2250. Right, it's a throwaway price in Bangalore, guys. Enter this referral code, you get 10% discount. KALEEMLIVE is my referral code. Enter this referral code, you get 10% discount. Okay, please do share my video, guys. Enable the bell icon if you are new here. Subscribe and enable the bell icon to get the notifications of my classes on YouTube channel. Alright, and thanks for joining me, guys. Have a wonderful day. Please watch, like and share my video, guys. Thank you so much. God bless you, guys. Bye. Take care.